Gravity is the sum of the Coulomb forces between two uncharged objects. In other words, the particles that generate gravity are electrons and protons. Think of a neutron as a pair of an electron and a proton. Let's consider the Sun and the Earth. The electrons in the Sun and the electrons in the Earth repel each other. The electrons in the Sun and the protons in the Earth attract each other. The protons in the Sun and the electrons in the Earth attract each other. The protons in the Sun and the protons in the Earth repel each other. Sum of the above four forces between the Sun and the Earth is the gravitational force between the Sun and the Earth. The forces of attraction and repulsion between objects are almost the same, but the force of attraction is slightly stronger. The reason is that the Coulomb forces of attraction and repulsion are not the same. You may wonder why I say that. Actually, a Scottish physicist called John Robison has made such measurements. According to John Robison's measurements, the force of attraction is inversely proportional to the square of the distance, while the force of repulsion is inversely proportional to the 2.06 power of the distance. In other words, the result was that the attractive force was stronger than the repulsive force. If this is certain, it would seem natural that gravity would only generate an attractive force. However, the above measurement is quite old, so there is a problem with its accuracy. The question is whether repulsion really does not obey the inverse square law, or whether John Robison was mistaken and in fact it does obey the inverse square law but the repulsion is simply weaker than attraction. If it does not obey the inverse square law, then the physics needs to be reworked. If it is simply that the repulsion is weaker, then we can simply multiply the Coulomb constant for the repulsion by a value slightly smaller than the Coulomb constant for the attraction.